welcome to this talk about domain primitives. That turns out to be a design concept that over the years have been really beneficial to create good software. And in order for you guys to see that, we are going to cover examples where we model like a room number, exchange rates, and money, and those kind of things.
And we're also going to take those domain primitives and put them in action. Especially, we're going to look at and share some ways we have been using them to get a foothold in legacy systems. So if you've got a brownfield code base, how can you use these to start getting traction? And we'll share a few things that you might be able to do starting Monday. And you will actually have finished a first small step at Monday lunch.
And of course, the title says here, and like you heard in the introduction, using this concept will actually give you a lot of security benefits. And that's something that you are going to, I guess, understand at the very end of this talk, because those security benefits are implicit. So, but before we jump into that nitty-gritty details, let's have a quick word about us.
Yeah. Daniel Dorgan. Who
yes.
are you?
I usually go by the names Coder and Quality Defender. I'm a developer at Omega Point, and I specialize in the crossing between software development and security. And who are you, Dan?
Dan Brooke-Johnson. Well, then I'm the secure domain philosopher. I'm a programmer at heart, security enthusiast, and doing a lot of agile stuff, high and low. And, well, so this talk will also be a combination about some philosophical aspects and some nitty-gritty, down-to-earth code aspects.
Yes, because we all know that code is king and philosophy is weird. Right.
I can agree with that. So we're off Stockholm, Sweden.
Yeah.
Omega Point, as mentioned.
So if you fall asleep, I have to run away. Here are the key takeaways today. So a domain primitive, what's important about that is it's really native to your domain. And that means it's specialized to the context where it lives.
Also, domain primitives should form a conceptual whole. It should be not, we try to avoid having bits and pieces lying around in the model or in the code. We will want to push them together to form a conceptual whole for clarity and security.
And this also improves your overall design, and it actually, I guess, lifts up the ubiquitous language into your code, and you will see that it becomes really easy to read.
So let's start.
Yes.
We're at a hotel, and I think this is a picture of a hotel room, so we might want to model that.
Yes, as you see here on the left, we have a conceptual model, right? And I guess a room, you can have a bathtub.
That's or not. It's right. A Boolean.
There's a guest associated with this, and the booking. And there's a room number.
Yeah, which is apparently an int.
An int, yeah.
It's an integer. Room numbers are integers.
So what's the problem by using an integer as a room number?
Well, if we say that it's just an int, it sounds like something really simple. But are integers really simple?
Well, if you look at it from a mathematical perspective, we are actually saying that an integer that needs to be part of Peano's axioms, and it also needs to be defined as an abelian group, right? It's actually an abelian ring because it's closed under
multiplication and multiplication. So an integer is not just something. Integers are a wonderful, complex, and really intricate field with a lot of wonderful properties. So saying that something is an integer means that we say that it behaves, it walks like a duck, it talks like a duck, then it should behave like an integer. So let's take room numbers to a test.
So if we're saying it's closed under addition, that really means that we can add two elements, again, another element in the same set, right?
Okay, so we had 25, 14, and if we add that to 25, 15, we'll get
So that's
5029.
right.
Is that a room number?
I mean, in theory, that could be a room number, but I know at this particular hotel we only have 26 floors, and there's no room number 5029. So that's kind of weird.
And in general, it's not a room number. And also, if we take another property of integers, that you got an inverse. Well, room 2614 would have an inverse room number minus 20. Nah. Room numbers do not behave as integers.
It also makes no sense to have an identity room, right? What's the identity room?
Yeah, the correspondent of 0, the room you can do nothing with.
So modeling a room number as an integer, it sort of makes no sense, even though it looks like an integer, right? But it isn't an integer.
Okay, let's make another try. Is it a string?
Well,
it kind of looks like a string.
That's usually the representation many choose when they have something generic, right?
Yeah, that's a representation, but is it a string?
Well, if you think about it, what kind of characters are legal in a string?
In a string? Well, any Unicode.
Right, and
like
that would not make
Greek
sense.
letter phi.
Right, so you would not put that inside of a room number, right?
No, you'll have strictly digits, 0 to 9.
So I have actually a subset of whatever is possible in a string then?
Yeah,
Okay.
I can go with that. So what operations that are allowed on a string are allowed on a room number?
Well, let's try the most obvious one, substring.
Substring?
Sub-room number, would that work?
Subroom number? Well, no, not in general.
But-
That's an interesting special case, though.
It could be.
If you throw the last 2 digits of a room number, you'll actually obtain the floor number.
Ah, so here you see a string fits pretty well, right? Or wait a minute, let's concatenate. A concatenation operation is
We
valid.
concatenate 2 room numbers. No, that does
Ah.
certainly not make sense.
Okay, so what we can see here is that even though we had one operation that sort of made sense, then all the others don't.
Okay, so it's not an integer. It's not a string. What is it?
Well, then it's a room number.
It's a room number. It's something that to the hotel domain is native to the domain. Anyone who works in the hotel business understands what a room number is.
But before we dive into how this would look in code and how we should represent this, let's actually have a quick view at what really happened if you look at this from a domain perspective, so in context perspective. On the left there, you're actually seeing, the hotel domain has embraced the mathematical domain when we decided to represent the room number as an integer.
So what we're saying is that integers are part of the hotel domain. That's what we're saying.
But the problem is that then it has to be in a Abelian group.
Yeah, and Abelian groups are not anything that comes natural to people that work at the front desks or guests visiting hotels. That's not actually an element of the hotel domain. So the mathematical domain is actually another domain.
So what we should actually use is a context map between the hotel domain and the mathematical domain.
To clarify what we are actually doing. In general, to clarify things, context mappings are wonderful. We think that out of the toolbox that domain-driven design provides us, context mappings are one of the most valuables. Use them whenever you want to. You can't fail doing context mapping.
So if we all agree that a room number is really a room number, that means we have certain definitions and rules associated with that particular object, right? So if you look at this from a code perspective, this is Java, by the way.
Of course, there will be code. At the end of the day, there will be code.
So you can see here that it's actually immutable. It doesn't have an identity. So that resembles a value object. Oh, that's sweet.
Yeah, definitely. This fulfills the design stereotype value object. It's formed as a value object.
But there's another interesting detail here, and that's what's happening in the constructor. And that's where we do the validation here, for instance. Like you see that we first check that, is it a valid floor? Does that integer value that we received, does it contain a valid floor number? For instance, 2514 would say, oh yeah, this is, floor 25. If you pass in -1, that would not be a valid floor in there. Also, there seems to be a limitation when it comes to number of rooms. I guess the room number can only contain, between 1 and 50. You can have maximum 50 rooms on a floor, I guess.
So the essence of this is that upon constructing such an object, a room number, we actually ensure that this is something that is valid in the hotel domain. It cannot exist. A room number which is not a valid room number simply cannot exist. Wouldn't get through the constructor.
And also, like we see that, remember the integer had all these interesting operations that were allowed, also the string. But the room number, I guess this only allows you to use the floor operation. Then you can get a floor out of it. And it could perhaps contain, I don't know, if it's an odd number, that might mean that it's on the west side and so on, right?
Or facing the yard or the street, or
right.
Special numbers for junior suites or something like that.
And as it turns out, this is a domain primitive, but there is a definition for this.
So, a value object so precise in its definition that it, by its mere existence, manifests its validity is called a domain primitive, which is a quote out of the upcoming book, Secure by Design,
yes.
Staring at the Bookstore close
wow.
to you, any year.
Yeah.
But what does this mean in plain English?
Well, if you think about it, the domain primitive is something that really means something in your context. Like room number, that means something in the hotel domain. Yeah. They talk about room numbers, you check out a room number, you say, hey, I want to check out a room number, I put this on my room, and so on.
Also, we ensure the validity. It can't be invalid, according to the domain rules.
Yeah, you can't really say, I'm checking out a room -1. That doesn't make sense.
That could be fun.
And it also resembles a value object, that stereotype, which is the neat part, because then you have all those properties as well.
Yeah. I think we should proceed, but hey, wait. I need to change some money. I've got 100. Do you have 250s?
What? You mean now?
Sure, they can wait. What the fuck?
Okay. There you go. 250s.
250, 100.
All right, thanks.
Excellent.
You do that
This
afterwards.
Grant guy looks good.
Grant?
Yep.
I have Greta Garbo here.
Fun?
What? You gave me 100 Swedish crowns. That's a tenth out of what I gave you.
No. I gave you 100. I got 2 times 50. That's 100, according to basic math.
Yeah.
What's your problem?
Okay, you know what? Let's move on to the next example. We'll take this afterwards, I think. Yeah.
Okay. I don't want to bear any grudge.
Okay. There you go. Yeah.
Even I must say that Greta Garbo is better looking than Grant.
Yeah. All right. So we're entering the money example here, right? And what you just saw there is that when we talk about money, we have an implicit understanding that we also have a currency and the amount, right?
The interesting thing that in most code bases, this implicit understanding is not manifested explicitly.
So if you look at the piece of code there we have on the top, we have represented, I guess, money as a double. Regardless that doubles is not a good representation of that, but it really is the amount. And then, obviously, the bank service requires the currency, so we're going to fetch that.
So as an afterthought, it's like the amount of money is being passed around as a double, and then at the last possible location, we almost as an afterthought realize that, oh yes, the bank service needs the currency as well. So then we go to the currency service that this recipient needs and fetch that currency and then add it to the payment.
But then, really, I mean, now our example is kind of, theatrical, right?
Yeah.
But in the real world, would this ever happen?
It actually has happened. We worked for a client in 2007 when Slovenia, a European country, changed from its historical currency and entered the European monetary
Union.
union, that is, they switched to euro. And over New Year's Eve of 2007, there were a lot of long-running transactions where you had orders that were set in the Slovenian currency and that had subsequent partial deliveries and partial payments over a long period of time. Parts of those after New Year's Eve. And they were noted that you're going to pay this amount. But however, after New Year's Eve, when you look into the currency for this recipient, it suddenly says they're going to be paid in euro. So they were going to be paid the same amount, number-wise, but in euros instead of the Slovenian currency.
Would you say that losing money is a security problem? I think most companies agree.
So they, of course, they found this in advance, and they had to do a pretty substantial work to avoid this and to identify whether this order were part of season 6 or season 7 and what part of it were, and it was paid, and they managed to patch it up, but it was a heavy work to get it to work properly.
But we all know that, you know, money is really a conceptual whole that we talk about, right?
You can't talk about just amount, you need to have a currency together with it as well.
So therefore, we should actually model this as a conceptual whole, as a domain primitive. And in the example below, we've actually introduced money instead. And remember, money contained both currency and amount. And suddenly, that piece of code doesn't seem to have any logic left. It's kind of weird. It also somehow speaks to you in the ubiquitous language.
So when we say domain primitives, they are primitive, they're native to the domain, they are pretty small, but they are not like just a wrapped int or just a wrapped string. They are things that carry a conceptual whole with the domain logic. In this case, the domain of payments. And they are able to do a little bit more intelligent things.
They're actually like tiny little intelligent machines. Whoops, here we go. Nope.
Yeah.
There we go.
There
Sorry
we
about
go.
that.
So imagine that you would be traveling to Sweden. Before you left, you would probably look up the exchange rate, realizing that it's 0.12. And then you're standing there in the bar and buying a beer and paying 98 Swedish krona and wondering, what? I have no idea how much this is in dollars. So you take out a note and you do the math and the rounding, and you come up with $12.33, or perhaps 44 cents, depending on how you round it. Which is a totally normal price for a beer in Sweden, by the way.
But the problem here is that you, as a consumer, needs to do the calculation, right? You're getting a primitive in terms of a double, for instance, and they say, hey, this is the conversion rate. Now you do the math, and if you make any mistakes, that's really up to you.
But if we think about it, an exchange rate is something that actually makes sense in the domain in and of itself. So why not model it? We model it as a rate and make that rate a specialized object which is capable of exchanging, this instance, from Swedish krona to US dollar. It's like a small machine. And then you can put in the 98 Swedish krona, turn the handle, and you'll get the result. And you do not have to take the burden of doing the computation and the rounding.
And the funny thing here, and the cool thing, is that the domain primitives are then acting as building blocks to a bigger, more complex object. Sort of like bricks when you build a house or a castle or something, right? And each one of those intelligent, tiny machines are actually in, how should I say, they're part of a greater whole, right?
So this idea is, of course, not new. Guy Steele had an excellent presentation at Uppsala 98,
Yeah,
I
it was a long
think,
time ago.
named Growing a Language, where he starts with a very primitive language consisting of very primitive words, and then subsequently using that language to build a richer and richer language during his presentation.
And the cool thing here is also when you talk about security, is that you're sort of injecting security in your complex objects. So by having tiny security pieces, you're actually getting, better and better security as a whole.
So that presentation, recommend Google it. Abelson Sussman in their SICP book were also talking about how you pick a layer of languages. So this is a kind of idea we want to promote with using domain primitives. Use them to build more and more intelligent and powerful things to stand upon.
So now we actually understand that the domain primitive is something that's native to your domain, and it contains a lot of intelligence and
Forms a conceptual whole.
and all that.
Yeah.
But
So what can we use them for? Can we put them in action?
absolutely.
So let's start with greenfield projects. Anyone here been a greenfield project?
Anyone?
It's so simple.
Oh,
Of course, we all know how to apply this to greenfield projects. You start with talking with your domain experts. You start coding your domain primitives. You build stuff, and it's kind of like not an interesting story any longer. Everything is nice and green and fine and dandy.
But we all know that the rest of us live in the brownfield domain, right?
That's what it's like.
Yes. The mud is so deep, you can't really do much about it. Things are just the way they are.
And
right?
your truck is way too small to handle this.
Yes. But the cool thing here, domain primitives is something that you can start using on Monday.
So
But
we want to share with you something that we used a couple of times. We think it works well. A way to get a start in a legacy code base. It's a few steps, and we'll cover them, and there's few variations. So how do we start?
the first step is something that we actually call draw the line, or finding a semantic border. Right?
Okay, so we start searching for a part of the code where room number makes sense.
Yeah, if you think about it, in your legacy code, if we are we're dealing with room numbers, that means that there are places where you have an integer value, is from the generic domain of math, right? Suddenly, there's a transition in semantics somewhere, where that int is no longer really an int, it's a room number. Within this context, it's a room number, right?
So we search for a cluster of classes. It might be a package or a module or something that's deployed together, and draw the line around that and say, here is where we have our context. This is where we want to work.
And you're saying that within this context, I'm not going to accept, the general operations of an integer. I'm also going to put certain, requirements on that when it enters this.
So we identify the methods that cross the line from the outside. The checkout method, for example. It's called from the outside, and it's executed by the inside.
So if you want to do it the harsh way,
yes, let's play hardball.
then what you could do, remember that the room number class that we saw earlier, it contained a lot of validation logic that was applied during construction. That means that if we take that integer value and we try to instantiate a room number object, a domain primitive.
So we've added this boldface line. It doesn't do anything. It just enforces the validation. On the inside, we're still using the same room number int parameter that we got. So we're not touching a lot of code. We're just adding a line.
The only problem with this is that if you're in a legacy code base and you introduce this,
you might have legacy data in the database.
And you get fireworks, right? Because it throws an exception. Everybody goes like, you broke our system.
2% of the data in the database were not formatted as expected.
So in that case, the bugs have always been there, but you get the blame. And we don't want that.
You want to start doing this domain primitives and the entire system just blew up?
Yeah.
You think that's a good idea?
So a softer approach to this is to actually check the validation, sort of like peeking data in a stream. So what we do is that we're going to try to apply the validation logic, and if it fails, we're going to report it. That's the only thing we do. So therefore, we can start to analyze our data quality.
Okay, and work with it. Perhaps we need to contact customer service who will get in contact with the customer who will change the data. Perhaps we can do something, just sanitizing it in the database through automatic means. But after a while, we come to a level where we actually have an acceptable data quality,
So
which would enable us to do the hard.
when you actually have that, and you're confident enough, you say, you know what, the data quality is good, I'm not going to take this any longer, I'm actually going to move on and start hardening my API.
What we do in that case, at that moment, is that we actually change our external API, telling the clients that, no, we do not longer accept random integers. We want to have room numbers communicated to us.
Because a room number is something that we understand. It's something that makes sense inside of our domain.
Okay, so now we come to the state we have hardened our domain. We do this trick repeatedly for all the methods, all the parameters, and we have suddenly something that shows a domain which says something. It's not built on integers and string. It's built on domain primitives and other building blocks that we create from them.
Actually,
So we're in a pretty good place.
we are, and I just want to clarify one tiny little thing. It doesn't mean that the consumer creates that room number. Perhaps it could be, it could be the API that's, in a REST boundary, right? So they will send you JSON or whatever format, and that they need to just comply to whatever rules that you have, declared in your documentation. So.
Okay, so now we got to create a nice wall that shields our subdomain and enforces the model to the outside.
Yes, and you could in fact stop here, but you still have the headache of having crappy code in downwards or inwards, right?
If you stop here, you leave money on the table. We don't want to do that. So what do we do next? We look on the inside and find stuff that are doing a lot of detailed work. We often have cluttered entities and services. So what can we do about them?
So here we actually have a different domain, to be honest. This is an order object, an order entity. And apparently you can add items to it. There's supposed to be, ISBN numbers and quantity of that.
So it's a book, online book sales.
Mm-hmm. And how funny, quantity is an integer. I could probably add -1 books.
So that would mean that I would give you money
That's right.
for not buying one book.
No, that's sort of a discount service, I guess.
Yeah. That could never happen in reality.
Right.
But if we look at the ISBN, we see that the ISBN is the entity here is taking the burden of validating the ISBN. And it does all the things that should be done when you validate an ISBN. Checks got the appropriate length, it checks that it's got the appropriate characters, and checks that the checksum is all right.
Checksum.
Yeah, there's a checksum in
You forgot
ISBN.
to add it. You forgot to add it.
No, I didn't. Oh, crap. I added that to the other 8 places where this validation is done. Apparently, I forgot to add it here.
And that's usually what happens when you have separated your validation logic from your data, I guess.
You see, there's so much other code that you can't really see what this entity is really doing. It's checking in the inventory and putting it in the basket. That's what it does. That's the purpose of this entity.
So the remedy to this is, of course, to introduce domain primitives. And if you do it, it would look something like this. The ISBN primitive is actually containing now all the validation logic that applies to an ISBN.
And hopefully the quantity is validating that you're not trying to trick me into buying minus one book.
Right.
And thus fooling me into giving you money. Now you can have your money back.
Yeah. I guess also what it means that we can't order 2 billion books either, because integer max is probably not okay.
Oh, so you mean that quantity would capture domain understanding of what's a sensible amount of books? Max int books might not be what we can handle in our logistics.
So the other interesting part here is that the ubiquitous language suddenly starts to speak to us through the code as well. Because a domain expert could probably read this. It says, inventory, available books, ISBN is greater or equal to the quantity. Yeah, sure, that makes sense.
We actually do this. We sit down with the domain experts and to explain to them, okay, I'm sorry, there's going to be a little bit weird anti-punctuation, there's going to be word order is going to be a little bit awkward. There will be some parentheses you need to ignore. But they can actually sit down and we can read it together. They would never be able to write the code. But they can read it, and they can read it in the domain language, and they say, yeah, that makes sense. You check that the available books are greater than the quantity requested.
So then we have now learned that we can, harden our APIs. We can start to inspect or learn about the data quality and declutter our entities. What about services?
Yeah, that's another neat trick of services. You remember the exchange rate? Often there's an exchange service that hands out integers or doubles or some other primitive. Often they look into a database and then they just serve out something you look up in the database. Now, what are those numbers going to be used for? Well, the double of the exchange rate is going to be used to exchange currency. So why not make it return an intelligent machine instead? So we're having a rate converter vending machine. I want a converter that can convert between Swedish krona, US dollar, clack, boom. There, I've got one. This is what I bring to my travel to Sweden.
And this is something that we want to see how it looks in code, of course. And there on the left, you see how it looks when you don't use that intelligent machine, right? And this is probably how your legacy code looks like. And so you need to do all that, rounding stuff as a consumer of it. And yeah, it gets pretty nasty. But on the right side,
you're using the intelligent machine, and the code is almost not there. Also note that if you would try to convert Danish kronor using the Swedish to US dollar machine, it would protest. You can't accidentally use a conversion rate for something it's not applicable for. Another common source of bugs.
But Dan, also, one thing that strikes me when I look at all of this is...
All of this looks nice and dandy.
Right. But if you think about it, doesn't it become a lot of classes?
There are some objections that often come up. There will be a lot of classes. Yes, to a degree. Those classes, however, will be very clear. You will not doubt what a room number actually does. In the same way that none of you doubt what the string class does. You just accept it. You use it, and none of you have ever felt the urge to go into the string concat and really check what it's doing because you don't trust it. But you might have done it out of curiosity, but not because of distrust. We want to have domain primitives behave the same way. You do not distrust them. So even if there are many, you feel no need to know the inside of them when you're using them.
But I think it's also important to note that a domain primitive represents something that you talk about and makes sense in your domain.
So a room number would only not be sensible to the cleaning staff. It's also sensible to the guests and the front table.
And the booking flow, I guess, and all sorts of things.
So the domain primitives will be reused all over the code base. So how many classes do you get?
Well, it really depends on how many concepts you have in your domain.
Yeah, but not
yeah.
that many as you might imagine. It's not a new domain primitive for every single parameter of every single public method.
But also one thing that people tend to criticize is, isn't this really overly complex?
We're building all these complicated machines.
I mean, I know it's not an abelian group, a room number, you can't add them, but
Can't I just use an integer?
yeah, why can't I do that?
But, I mean, you still have to handle the complexity. There are some complexity that the validation of what's a sensible room number has to be done sooner or later. So you can't shy away from the complexity. You have to put it somewhere. Well, either you put it in the domain primitive, or you have it somewhere else in the domain, probably on 3 or 4 places, at least. So, remember Einstein? Things should be made as simple as possible, but not simpler. You can't pretend to have a simpler solution when your essential complexity in the domain is more complex.
And you should
Then you're cheating.
you should really remember this, because this is going to be interesting from a security perspective soon. Okay, so what about performance then? I mean, isn't this, poor performance?
It should be poor performance. We all remember Java 1.0, where it was a heavy work to create objects and a heavy work to destroy objects.
Oh, well, okay. Let's
We
jump
all
to
remember Java 1.0, aren't we?
Yeah. I mean, the garbage collector only touches live objects. But we must admit, though, that there might be cases where performance is so crucial that you can only do bit shift operations, right? And in those cases, you might not do this. You might not use this design pattern. And that's perfectly fine.
Because then your critical complexity is not the domain understanding. Your critical complexity is performance. And then you should focus on performance.
And I would say like 99.9% of all applications, the domain is where the complexity lies, right?
So in a modern computing environment like the JVM of today, or many other comparable, it's basically a very low cost to allocate an object, and it's basically a 0 cost to discard of an object, because as Daniel said, they only touch live objects. So in practice, this is not a performance issue. Also, if you're touching the database, then we are talking about making domain primitives is in the range of nanoseconds or microseconds. Touching the database, you're up on milliseconds. So you're doing something that's 1,000 or 1,000,000 times slower, meaning whatever you do in your computational space doesn't really matter. It's the performance of your database connection that's the overarching concern for performance.
So we talked so much about design and good stuff. We should really jump into the security part now.
Okay, so what has this got to do with security?
Well, if you think about this, a domain primitive sort of seals tiny little holes in your application, right? Like we said, a room number can only be a room number. It cannot be a generic integer. The same thing is, or at least it's easier to understand if you take a string. If you have a very precise definition of something that only uses a subset of whatever characters you would use, you can't use other characters because those would not be applicable in your domain.
So an attacker is often making an inventory of all the places of your application where you input data, all the small holes. And then they start sending in probes to see if this hole has some connection to the infrastructure down under. So for example, the
SQL injection flaw, right? Everyone knows that. I guess the basics of that is that you somehow are able to inject a string of text that gets executed as a SQL data command.
So to maliciously enter the domain, the application, and when it got down to the database, it suddenly blows up. You might remember anonymous attacks a few years ago. They were attacking, for example, they were actually cracking some major media websites. The essence of their attack was a SQL injection. A maliciously formed data string was sent into a valid input hole. And when it finally reached the database, it wreaked havoc.
So if you're using generic types, like ints or strings, or it could even be more advanced types like points and stuff like that, color, even though your intention is only to use like a subset of it, to say I only intend this to be a room number, not everything else, an attacker don't see it that way. They see it as the El Dorado, right? They're like, oh wow, you actually accept strings, so I can send any string in there. But if you use a domain primitive, you all suddenly have defined something that's very precise in its definition that it cannot even exist if it's invalid.
So we're not claiming that this solves the injection flaw completely. But what it does is that it eliminates the attack surface enormously. You might still be in the situation that your valid room description might be a format that was rich enough to form an attack. But your room number will not be. Your hotel name will not be, etc., etc., etc.
So, of course, you guys wondered, there is a book.
Yeah. There's a discount code which is valid for this. We'll tweet it so you don't have to make notes.
But the cool part about this book is that you as developers can learn about using good design principles and focus on design and get security as a benefit instead of thinking security all the time. And I think that's amazing.
And this builds heavily on a lot of concept from DDD. We have a lot of inspiration for this work comes from domain-driven design.
All right, enough about that. What's the key takeaways?
Yeah. So, to repeat what we started with, domain primitives are things that are native to your domain. Integer is not. Hotel room hotel domain will have room numbers. They are native to your domain.
And of course, they need to form a conceptual whole. Remember the money example, right? We don't talk about amounts only. We also talk about the currency. And therefore, we should model it as a conceptual whole.
Thus, building a brick wall of abstractions. And if we put them in action, it's an easy way to start improving existing code and also making it more secure.
Right. I think we actually have about 5 minutes left for some Q&A.
So, any comments or
Yes,
questions?
we need a microphone.
We have a microphone going.
To the gentleman over here.
Hello. Yeah, so my question was that would you recommend converting all primitives to domain primitives, or would you have, in some cases, you think it's not needed? Could you give an example of when you would not convert it, if that's the case?
If we look back at the chart with our domain and the subdomain we're using, we're open for that. In some cases, that's actually a full domain that you can embrace. If you actually allow all colors, then you can use the color library as it is. But in general, we'll say that kind of like a starting point would be to think about, do I need to restrict this?
And also, I think it's important to say that, is this a concept in my context that doesn't make sense to represent? I mean, can I treat it as a generic string? I don't even care where it is, right? If that's the case, sure. But usually domain primitives are supposed to be used when there's a concept that makes sense, that everybody talks about, that you use. So.
In our experience, we have got used to wrapping anything we see. We never, ever used anything from a standard library without wrapping it. And that was because of the poor quality of a lot of standard libraries. You all know the Java util date. you can't use Java utildate without wrapping it up.
Well, you used to anyway, right? Yeah.
But what's happened recently is that actually there's come out more and more libraries with high quality. For example, Date and Time is a library with a pretty decent quality, with a lot of very neatly geared value objects that actually make sense. If I want something that is just a date, not the time point of the date, not midnight, not time zone, I want to have something that expresses the date of the 20th of September 2017, then there is a class for that. And then I do not need to wrap it up. So we have been used to wrapping up everything we see, and we are slowly realizing that nowadays we can actually incorporate more and more high-quality libraries.
All right. There's another question over there, I think.
Good talk. Thank you, guys.
Thank you.
Thank you.
So when you deal with external entities, for example, in healthcare, there's a lot of really legacy systems that you integrate with. And they have a lot of data. And would you say, there's probably 50 sets of data that you need to map to your domain. Would you actually go about mapping every set of data to some,
Okay. So
where do you draw the line?
Yeah.
So yeah,
I have a second
I
question
can
too.
feel your pain. I feel your pain.
I think it's important to analyze how that data is used, right? If you're acting upon that data, I mean a field in there or whatever it would be, you probably need to have certain definitions of that data, right? But there could be other data that you say, I don't even care about data, this is just text or whatever it is. We're never touching it. In those cases, you wouldn't even bother, right? I mean, those you treat it as text. Maybe string is actually the perfect model for that. But the ones that you are actually dealing with, they probably make sense in your domain.
To add to that, if you've got like a large number of data sets, it might be unfeasible in the time you got to actually do the deep analysis of wrapping them all up. And in that case, well, you have to do a classical security risk mitigation analysis. What are the risks involved of not enforcing the domain, the domain rules? Because that's what you're trading away. I'm trading up simplicity of doing the technical connection, but I'm trading away data security. What are the risks involved? And I would guess that in some project, depending on project deadline and so forth, you'll have to make a conscious decision of whether to wrap it up or not.
Okay.
So I guess the answer is depends.
Yeah. Very consulting answer. Second question, do you wrap primitives, domain primitives with other domain primitives?
You could.
Do you guys do, is that a...
Of course,
I guess it depends.
in some examples, you do it in order to build more and richer abstractions.
Right.
Of course, that's natural. But if you've got a domain primitive that's native to your domain, it doesn't really make sense to wrap it
Probably
one
not
more
necessary,
time.
yeah.
If it's already native to your domain,
Sure.
then it is. Wrapping it for building high levels of abstractions, definitely, yes.
Yeah. Okay, last question, I think.
Yes, thank you for that. You talk about wrapping primitives and strings, right? I'm following object calisthenics for a while. You've heard about this? They're
Pardon?
Object calisthenics. They go also in about wrapping primitives, but also wrapping
Okay.
collections.
Okay.
Okay.
Is that something you talk about in your book too? Because this is more about primitives and strings, right?
Mhm.
But yeah, if you have rooms, which is a collection of room, do you advise on wrapping that too?
Interesting question. Interesting question.
I would say it really depends, again.
Of course.
If the notion of rooms would make sense to talk about in a group manner, then of course that is a concept that needs to be abstracted, and there are certain rules associated with that. Then you would define it. But if you only talk about a room, then your primitive would probably be a room and not the collection of that room. So.
Another source of insight might be the code. If you're looking at the code and you realize that I'm repeatedly iterating over these structures and doing intelligent stuff, that might be a sign that rooms as such is an interesting abstraction. If you create it, it can start swallowing functionality and turn into one of these intelligent machines. So thinking about it from the domain perspective, but also thinking about it from the code perspective might give insight. I think something that Evans often talk about is that the source is the source code is a source of wisdom. When refactoring, we gain insight, and we might actually come up with ideas of abstractions that the domain people has not yet start forming. And that might be such an example.
Thank you.
Okay.
Yeah.
Yeah, unfortunately, that brings us to the end of our time. Please join me in thanking Daniel Dehagen and Dan Berg Johnson.
Thanks a lot.